Okay, hi everyone. I'm Simon Benninga. This was Jason Kramer, who's from the Oxford University Press, and they're the publishers of the book. They paid for the lunch. Thank you very much. So I'm going to talk today about issues in teaching finance with Excel. There's a slight commercial angle here, obviously related to the fact that I have a book in this area, but I'll try to keep the conversation more or less general and talk about issues that I've come up with against in teaching this. I welcome your inputs and questions. I don't want to take more than about 50-55 minutes. That's sort of the limit, I think, for something like this. I think the background here is sort of is fairly obvious, which is we still tend to teach introductory finance courses with a calculator, which I think everybody will agree, except for the fact that it eases the problem of how do you give an exam, is sort of a useless contribution to pedagogy. So the student comes in and she has a Texas Instruments or an HB or something like that, and that's a great way to get a closed book exam, but it's not a very good way to teach finance. Also, it turns out that Excel is one of the top marketable skills that students take out of a business program. So I get lots of letters from people saying, I took a BA or an MBA at some respectable place, and now I discover that I need to know Excel. And then the last thing is it's fun. So if I can start with a tiny bit of humor, I'll tell you about sex and Excel. It even rhymes. So the first edition of this book, I very quickly found out that if I wanted to know how the book was doing, I didn't call Oxford University Press, but I looked up the book website on Amazon and sort of tried to figure out from there whether anyone was buying the book, if people were making comments. And here's the book website. I don't do this too often, not more than once every hour or so. And at some point, somebody had posted a comment. Now let me tell you about comments. So here's what I don't do. I don't publish comments on my own books, and I don't publish negative comments on other people's books, although I've been tempted. But every once in a while, someone will write me a nice letter, and I'll say to them, well, you know, if you like the book, maybe you would like to post a comment on the Amazon webpage. And the lady down here, I know you can't see this in the back, but she had used this book at UBC, and I knew she liked the book because she sent me a picture of herself in the email. I have to say, in view of the topic of this little slideshow, fully clothed and with her cat. So I said to her, well, maybe you'd like to post this, and she did. She posted a very nice comment. But the guy on the top, who was the subject of these slides, his name is Gustavo Jimenez, and I'd never heard of him. So I was trying to figure out who he was, and you can click and say, you know, see all my reviews. And so I clicked on see all my reviews, and at this point, Gustavo had reviewed only 2 books for Amazon. One of them was my book, and the other one, those of you who can't read, is a book called Sexual Positions, Games Lovers Play, which unfortunately is out of print. There's different versions, I'm sure. So I was extraordinarily flattered to be included in such a high quality big one. I sent this to absolutely everybody. I sent this to my sister, and she said, I have a terrible problem. She said, I don't have the money to buy both of these great books. Which one should I buy? Anyway, okay. So here's what I'm going to do. I'm going to talk a little bit about what I call slightly advanced basics, some stuff that I think you need to do before you actually start teaching with Excel. I'm going to show you something called get formula, and I'm going to show you something about resetting some Excel defaults. There's another thing that's data table that many of you probably know that I think is a necessary part of an Excel course, Excel-based course, but I'm going to save that until I do some pedagogical examples. Then I'm going to do 3 pedagogical examples. One of them is net present value internal rate of return, and there I'm going to show you data table. The next one is what I call extensive versus intensive calculations. I have a point to make there about how you might present things to your classes. And then the third one, I will talk a little bit about drawing the efficient frontier, something that we do in all finance classes. So there's no effort made here to be inclusive. I'm not talking to you about how you teach a whole course. I'm trying to hit some highlights and talk to you about some pedagogical aspects of teaching with Excel. Then I'll end and I'll talk a little bit about teaching hands. I'll tell you a little bit about instructor resources that I'd be happy to make available to you. Let me tell you what's not in this talk. I have another book. It's called Financial Modeling. That publisher didn't pay for this lunch, so it's much more advanced, and it talks about stuff like optimization with multi-asset portfolios and Monte Carlo and structured assets. I'm happy to talk to you about this after we get through, but that's not the point of this this little talk. Okay, so let me start with some very basic stuff that I do at the very, very beginning of an Excel course. The first thing is, and it sounds advanced, but it's not really, is I show students how to add a formula to their Excel spreadsheets. Let me say, as a general bias, when I teach Excel-based courses, I try to restrict myself to an out-of-the-box Excel product. I don't use add-ins. I actually don't think I use very much fancy stuff. Okay? This is not an add-in. I'm just simply showing the student how to add something. What does Get Formula do? Get Formula is a very small VBA program that allows you and the student to annotate their spreadsheets, to explain what's going on in the spreadsheet. Let me show you how it works. Let me also say that on the file that comes with the book, so there's a CD-ROM in the book, there's a Word file, and the Word file says how do you add Get Formula to your spreadsheet. I have found, by the way, in teaching that this is not a problem for students. So I'm going to tell you about 2 things, data table and Get Formula. Data table, which is part of every Excel spreadsheet, is very difficult to teach the students, or difficult to teach students. It needs to be repeated many times. Get Formula, I can take 20 minutes and everybody understands it. Okay, to show you Get Formula, let me start with a completely blank spreadsheet. And maybe I should, before I do that, maybe I should show you what Get Formula does. So here's a spreadsheet in which I've done some kind of future value calculation. And you know, the question is, what's the future value in 2 years of $100 and 6% interest? And you know how to do this. And there's the answer, and this is Get Formula. This is actually a function that points to the cell and says, this is what's in the cell. And I'm going to use this throughout this, this talk, so you'll see what I'm going to do with it. Now let me show you how this works. So here's a blank spreadsheet, and now I want to introduce Get Formula, so what do? I hit Alt F11. Alt F11 takes you to the VBA program that is part of every single spreadsheet. It comes out of the box. Okay? And in VBA, you hit Insert Module. All right, let me tell you where I am right now. I'm in a spreadsheet called Book 2. It doesn't even have a name. And it's got some sheets in it, and I just added this thing. It's called Module 1. All right? And now I go to some place where I've recorded get formula, for example, in this sheet, and I copy this, I go back to my Excel, and I paste this in, and now I've pasted just a bunch of text into my Excel spreadsheet, and now I can use it. So for example, suppose I'm adding two numbers together, 2 and 3, and the question is, what is the sum of 2 and 3? I'm sure you've all wondered about that yourself. And now I type get formula, and you see that get formula identifies the contents of the cell. It's also dynamic, meaning if you were to put this in a different column, then get formula changes with the cell reference. And I explained to students that this is important because everybody who uses spreadsheets has had this phenomenon where you did something amazing and 3 weeks later you open the spreadsheet and you don't have the vaguest idea what's going on in the spreadsheet. So I say to them, when you do a financial model, which is basically what we're doing, when you do a financial model, you must annotate your spreadsheets. And this is my way of annotating spreadsheets. Okay, I'm going to close this down. And I'm going to close this down. Now, at the end of this talk, we'll send everybody this PowerPoint, and you'll see more of what's going on. Let me say that there's slightly more to this than meets the eye. There are 2 points here that you really want to make. One is the newer versions of Excel, so 2007, 2010, and 2011 for the Mac. Instead, in the old days, we had one file extension. It was .xls. Now we have a bunch of file extensions. In order for get formula to stay with a file, you must save it as a macro-enabled file. The user doesn't know about this. You can send this to anybody. But I set my default file saving format as .xlsm, and I show students how to do that. So that's one thing. Okay, so here's a typical page of where I'm saving something, and you see I'm saving it as an Excel macro-enabled workbook. The other thing has to do with security settings. By and large, this isn't a problem because the Excel defaults will take care of this, but every once in a while you run into somebody who works for a financial institution or some other place where they're so distrustful of each other that I don't know why the financial sector seems to work perfectly well, but that was a joke. And they've disabled all this stuff, so you have to reset the security settings to make sure that it will accept macros. And in this PowerPoint, I showed you how to do this. Okay, so that's the first thing. Here's the second thing I talk to students about. This whole thing, by the way, takes me about 40 minutes. The second thing I talk to them about is canceling 2 basic defaults that come with Excel. The first thing is the jump down feature of the spreadsheet. That's the one where every time you hit enter, the cursor jumps down. Okay? And I explained to them that that's great for accountants, but it's not good for finance people because we make a lot of mistakes, and when we put something in a cell, we want to be able to look at the cell and see what's written there. All right? So, this is trivial to do. You go into the Excel options. Under the advanced, for some reason, there's an option that says, what does the cursor do when you hit enter? And you unclick that button, and then it doesn't do anything. And the other thing that always irritates me, I have to say I'm originally Dutch, and we tend to be a little anal retentive, so maybe that's where this is all coming from. I find it irritating to see a spreadsheet where it says sheet 1, sheet 2, sheet 3, and sheet 2 and sheet 3 are empty, and there's only sheet 1. So you can always add sheets, so why not start with just one? So That's what you should do. Okay, so now that's the introduction. Now, let me talk a little bit about three, as I say, teaching examples. Let me start with net present value and internal rate of return, and let me right off say, this is not where my finance course starts. You know, we've talked about time value of money a little bit, we've talked about future value, so I'm really sort of trying to make a general point about how you might teach some of these things. Let me go back to a spreadsheet. And let me start by showing you this example. So here's a sort of standard, slightly advanced net present value problem. Slightly advanced because not all the cash flows are equal. So the discount rate is 11%, the asset cost is 1,000, there are 5 subsequent years of cash flows, and the question is, what's the present value? And what's the net present value? Okay? So what do I do? All right. Well, the first thing I do is I say to students, I really want students to understand this, and part of the understanding process is to introduce a significant amount of redundancy. Do things twice. Make sure that even if they don't understand the formulas, at least they understand what the hell is going on. Okay? So here's what I'm going to do. What's the present value of $100 at 11% if paid in year 1? And the answer is, I'm just pointing now, it's the $100 divided by 1 plus the interest rate. Now at this point I want to think a little bit because I'm going to copy. And so you want to think about absolute versus relative values. This is absolute, so you hit F4 to put in the dollar signs. Maybe you have to explain this, maybe they've had this in some previous computer literacy course. Close parentheses, to the power of the year. There's the present value. Here's the get formula. And now all I have to do is copy this. You know, you don't have to copy every single get formula, just a few, just to make sure that everybody understands it's the same logic in every cell. Okay, so now I know the present value. By the way, there's another point here. Another point is you want to explain to students they should never, ever, 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 ever use numbers if they can use formulas. Numbers is the way to death when you're building a financial model. Okay? Because you end up in some meeting and somebody says, what happens if you change this? And you say, well, there's no big deal about that. And then you change it, nothing happens. And that's because somewhere in this massive spreadsheet, you forgot that it's a rate instead of a number. So you want to make these points. So what's the present value of the cash flows? The present value is the sum of all these cash flows. I've already put get formula in here. And now you want to say to them, okay, Excel also has a function that does this. Now, unfortunately, as you probably know, this function is misnamed. So Excel's function for computing the present value of the series of future cash flows is actually Npv and not PV. That has a long history. It comes from the people who wrote VisiCalc at the Harvard Business School at the end of the 70s. And I used to, somebody who taught at Wharton for a while, we looked down our noses, not anymore. And I don't teach at Wharton anymore. So, but we looked down our noses at Harvard, so we'd explain to people, well, they didn't really understand the difference between the present value and the net present value. Never mind. If you want to calculate the net, if you want to calculate the present value in Excel, you need the Npv function. And here's the dialog box. And here's the rate. And for the values, you can just put in the stream of cash flows. You don't need to put them in individually. And now you hit. Okay. So I've done this twice. And I've made points about absolute versus relative. I've made points about sort of basic logic. That's all good and well. And now I want to calculate the net present value. I won't belabor this point because you all know this. So you need to take the present value that we calculated previously and add in the initial cash flow. And maybe I want to also calculate the internal rate of return. The internal rate of return function on Excel works beautifully. It's correct. You take the IRR of all the future value, of the present value, of the current price, and all of the future cash flows, and you hit enter. So here are three basic examples of computations that we all do. Okay? And now what I want to do is I want to use data table. Okay? What I really want to do is I want to create a graph like the one that we show students when we explain to them what is an internal rate of return. An internal rate of return is the discount rate for which the net present value equals 0. I want to create that graph. All right? And so what do? I have to set up the data table. Let me talk a little bit about what happens in the data table. How many of you use data table in your teaching? Okay? Less than half. All right? I won't embarrass you by asking you how many of you know data table. I will say that data table is an amazing resource, and it's very underused. I have a separate chapter in this book that talks about data table, and it's not trivial for students to understand. I go through a data table example at least 4 or 5 times when I teach an initial course. Because they're always saying, what did you do? Could you explain this again? And you know what? I understand it. Okay, so what's the structure of a spreadsheet with data table? Well, the first thing is you need an initial example. You need an example. In this spreadsheet that I was just doing, my initial example has the cash flows, the discount rate, the present value, the net present value, all that. That's my initial example. Then the data table refers to this initial example and recomputes it. Okay? I'll show you this in just a second. Let me also say that data tables, they're spectacular. It's one of the few ways I know that an ordinary student can stop a laptop dead in its tracks. You take a big spreadsheet and you put in 25 data tables, and even this, which is a fairly new Lenovo, will start to slow down to the point where you actually see it computing. Okay, let me show you how to do this. So here are the data table basics. You have to make the table structure, and you have to say what it is you're varying. I'm going to vary the discount rate. And then you have to connect the data table to the basic example, and then you can use the command which in Excel 2010 is data what if analysis data table. So let me show you that in this example that I was working through. So here's my example over here. This is going to be my data table. The first thing I have to do, I've labeled it. As you know, I'm a fanatic about annotation. Okay? And you see that there's a blank cell up here at the top of the second column. This is the cell that connects the data table to the basic example. Okay? So in this cell, I'm going to write, I want to compute the net present value. All right? And just so I don't forget, I'll put in get formula. And you know what? I can tell you what the next step is going to be. The next step is going to be somebody writes a report, and you copy from Excel to Word, and you delete this. You can't delete the data table, but you white it out somehow, and then you really don't know what's going on. Okay? And so sometimes I show students at this point, you know, you can add text in Excel by using ampersand and writing things in quotation marks. So you say, quotation marks, data table header. So at least when she goes back and she looks at the spreadsheet, she'll understand what she's doing. Okay, so I mark the data table. I've connected it to the example. I mark it. I go to data, what if analysis, data table, and then I get one of those amazing Excel dialog boxes which no one understands. You know, it was originally written in some other language and translated several times. What this dialog box is asking is two questions. One, is the parameter to be changed in the left column of the data table or the top row? Maybe both. I'll give you an example in just a second of both. And the second thing is, so here, it's in the left column. And the second thing is, where in the basic example is this parameter? And the answer is, it's the discount rate. Okay, now I'm always wary when I do this because I figure this is a great place for me to be embarrassed in front of my students. So I say to them, I'm going to say a short prayer, and then I'm going to hit OK. And I get some results. So this is my table of what is the present value, the net present value at different discount rates. You can check this table. And the reason you can check it is because you have a fully worked out example over here. So here's a question. Is it true that when the discount rate equals 0, the net present value is 500? Actually, you know, this we can actually do in our heads, right? Except nobody knows how to add anymore. But if you don't know how to add, you can say 0, and you see it's 500. Is it true that at 10%, the net present value is $65? Yes. Okay, so that's one example. So I explain all this in this presentation, and I'll send it to you. All right, here's the second example that illustrates something that I call extensive versus intensive calculations. Okay? I try to teach a course which is not an Excel course. My shtick is I'm teaching you finance. Maybe you're learning Excel. Quite often students say, that was a great course, I learned a lot of Excel, and I say, yeah, I'm a little disappointed because I thought I was teaching finance. It's okay, but I'm not teaching some grab bag of Excel shortcuts. All right? And one of the things I really want is for students to understand stuff. Like, for example, in that net present value calculation, I actually computed the net present value. That's the power of Excel. Let me give you another example. So here's Angela, and she's 50 years old, and she has $100,000 in the bank, and she's thinking about her retirement, and she wants to make an annual deposit today and for the next 14 years, so 15 deposits, so that she has $1 million when she reaches 65. You know, we've all given those kinds of examples. And the question is, how much? All right? So the first thing I'm going to do is I'm going to set this up in a spreadsheet, and I'm going to do this in the dumbest possible way. That's what I tell students. I want them to understand. I'm not interested in fireworks. So to make these columns a little wider. So I set this problem up with an incorrect answer. So here's Angela. She's got $100,000. Her current age is 50. She wants $1 million. What would happen if she deposited, the interest rate's 5%, what would happen if she deposited $25,000 today and in every year for the next 14 years? Well, let's see. She deposits $100, $100,000. She has $100,000. She deposits $25,000 now. At the end of the year, she'll have $125 plus the interest. She will have $131,000, and $131,000 is what she will have at the beginning of the next year. And now you can solve this whole problem with 2 clicks. 2 clicks turns out to be sort of a standard Excel thing. So here's the first click. Let me use my mouse and get some. Oh, okay. So the first click is to do this for 1 more year. At the end of the 2nd year, she'll have $164,000. And now, if I just click this handle, it'll fill this in all the way to the end, and the last value is going to be $774,330. So is $25,000 enough? No. She wants $1 million. So how are we going to solve this? Well, one really simple way to solve this is to use goal seek. Okay, so you go to what if analysis, goal seek. Between us, at some point in this course, I would like to teach them solver. The difference between goal seek and solver is that goal seek forgets, mercifully maybe, every time you do something, it makes you start from the beginning. And solver will remember what it was you did before. It's also much more sophisticated, but this is not a sophisticated course we're talking about. So I'm going to use solver. I'm going to use goal seek. And the question is, set this cell equal to which value? Well, I want $1 million by changing, and what I want to change here is the annual deposit. Okay, and hopefully this will work. Okay, let's see. According to this, if I deposit $34,960.06 for 15 years starting today, I will have $1 million. So now I know the answer. Not only that, I know the answer at a level where the amount of Excel is basic, the amount of finance is basic. I mean, this should be comprehensible, right? I hope. Okay, so once I've got the answer, now I can start talking to them about Excel. Maybe there's a shortcut. And there is a shortcut. And it's Excel's PMT function. Now, I have to say that when I illustrate, I'm not, as I said before, I'm not giving a course here. So by the time I've gotten to this example, this is not my first PMT example. I use PMT payment to illustrate what would be the flat payment on a mortgage or a loan over 10 years or 5 years, and I show them how to amortize those flat payments into principal and interest, all the standard things that we do. It's all in Chapter 2 and Chapter 3 of this book. But this time I'm going to show a slightly advanced application of PMT, all right? Because it turns out that what you can do with PMT is you can ask it to set a future value. So the interest rate here is 5%. The number of periods is 15 periods. The future value. What's the future value here? Well, the future value is the future value of the actual deposit made annually, plus the future value of the initial amount in the bank. So I've put that in there. And then there's one other thing which has to do with type. And in Excel, this always has to do with whether the deposit is at the beginning of the period or at the end of the period, and here it's at the beginning of the period. And if you can, I wish I could make this screen larger. I can't enlarge this at all. If you look here, you will see that I got the same answer. And for students, the point is, I knew what the answer was. Now, let me show you how you can do a shortcut to this answer. But if you want to know what it means, go back and see the extensive example. Okay? You can't see this, but maybe you can see this. Okay? PMT is part of a family of Excel functions which shares the irritating property that if you put in positive numbers, you get negative answers. You know, Npv I blamed on whoever was developing VisiCalc 40 years ago. This is an invention of Microsoft, and every once in a while somebody sends me a letter and explains this to me. You know, positive payments, negative loans, I don't know. I find it irritating. So the answer here, if you see, it's not 34,000, it's minus 34,960. So you have to do something. You have to put a minus sign somewhere in one of the cells to get a positive answer. Okay? Nevertheless, it answers the question. And you no longer need this extensive table. Not only does it answer the question, it also allows you to do a data table. Now, I'm going to skip in this presentation. I have a one-dimensional data table, and then I have a two-dimensional data table. Because of my time, I really want to finish by 3:30. The trick is to finish before you finish, right? Meaning before people start to walk out. So let me show you only the two-dimensional data table. Okay, so here I have this same spreadsheet. I've cut out the whole extensive part because I can answer it all in one computation. And now what I want to do is create a table where I see what is the annual payment needed when interest rates change, but also when the initial deposit changes. So those are two dimensions. A data table, you'll remember, needs to be tied to the initial example. So the left-hand corner here, before it was at the top of the column, now it's the left-hand corner. The left-hand corner indicates that calculation we did before, and now it's just like what I did before. I mark the data table. I go to what if analysis data table, and now Excel asks me, what's in the top row? What's in the left-hand column? Show me where it is in the initial example. So the top row is this 100,000. The left-hand column is the discount rate, the interest rate, and you hit enter. And then usually I spend some time talking to students and asking them whether this makes sense. You know, so for example, you over there, one for me, you know, can you explain to me why at $25,000 initial deposit, as the interest rate goes up, the annual deposit goes down? Sort of basic type of stuff. Or can you explain to me why at a discount rate of 7, or an interest rate of 7%, the more you put in, that's simpler. The more you start with, the less you have to put in. All right, so that's my first set of examples. I beg your indulgence for the speed, but it's all explained here. Let me now show you the last example. The last example is something that we all do in an introductory finance class, which is we want to draw the efficient frontier. And as I said before, I'm just going to do this for two assets. Okay? So before I do this, let me tell you what I've already done. You can't come at this, you know, out of left field. So I've already talked a little bit about risk. I have a chapter in this book where I discuss different examples of risk. I've talked, including, by the way, one where I download a lot of data from Yahoo and show students what the returns were like over 10 years, the daily returns for McDonald's, the hamburger people. Great example, if I must say. I mean, it gives them a feeling for, you know, sort of what was going on. What was the largest return? What was the smallest return? I also assume that they, in this example, that I've already talked to them about averages and standard deviations and variances. Okay? I always, by the way, teach a class in which I say to them, this class is, it's going to be very boring. Okay? I mean, what are the two worst taught courses in the business school curriculum? Well, there's the accounting course, okay? And there's, I always tell them a joke about accounting. Do you know this joke? Can I tell the joke? It's going to be on this You can change the occupation. You have to be a little careful. This is about, it's not a dirty joke, but this is about the two male accountants who meet, and one of them has a new bicycle. You know this joke? And his friend says to him, "Where did you get the bicycle?" And he says, "You know, a strange thing happened to me. I was in the park the other day, and this very attractive woman came up to me on her bicycle. She saw me, she stopped, she took off all of her clothes, and she said, 'Take what you want.' So I took the bicycle." And his friend thinks for a second, and he says, even accountants like this joke, by the way, his friend thinks for a second, he says, "You know," he says, "I think you made the right decision because her clothes were probably worth less than the bicycle." So one of the two worst courses, you know, there's the accounting course, and then there's the statistics course where for some reason the professor walks in and gives them a piece of software that they will never, ever use again. And that's the piece of software with which you're going to compute all the statistics, right? And so I say to them, "Listen, I know you know this, but I'm going to show you," and I have a bunch of examples, and I show them how to, you know, download some data and how to calculate the mean and the variance, and it can all be done in Excel. So I've already done that. I'll show you some of that in just a second. And the point of this example is I want to get to that graph down there. Okay? So here's some stuff that I've also have shown them. So in this particular example, I'm using Exxon and Kellogg. Kellogg, I love Kellogg. It's got pretty stinky returns, but it's got a very, very low beta. So if you get to that far, you can talk to them about, you know, what's the beta of Kellogg. Often it's 0, by the way. So here's Exxon. I've downloaded annual price data. I showed them how to compute the returns. I showed them how to compute the mean, the average, and the average and the variance and the standard deviation. Here I've done the same thing for both of these, and now I can talk about covariance and correlation. Again, I don't start talking about covariance just by pulling out some Excel formula. I do it the long, tedious, hard way and show them the formula and multiply this times this and take the average. Okay, and then I can say to them, and there's a formula. But this example assumes that you've already done all of this, and then I take them in great detail through one portfolio example. What would happen if you invested 30% in Exxon and 70% in Kellogg? What would that look like? What would the variance be? All of that, as you know, is to make very basic points, which is that in a portfolio, the average, the mean return of the portfolio is the average of the returns, but the standard deviation is not the average of the standard deviations. Okay, hopefully they understand some of this. And now I can pull this up. And again, I'm going to use data table. So I'm going to use data table. My basic statistics are up here. And here, a data table always starts with one example. So my example here is 50% in one asset and 50% in the other asset. I won't belabor the formulas. I'm sure you all know them. And that's one portfolio calculation. And now I can build a data table in which I reference the standard deviation here, and I reference the expected return here. So that's an example up here. Okay? Notice, by the way, notice that I've put the standard deviation to the left of the average return. And the reason is that I want students to use an XY scatterplot to produce, that's by far the most useful graph in a finance course. And the XY scatter graph will produce this, and it will automatically put the first set of data on the x-axis and every succeeding data set on the y-axis. Okay? I'm not going to take you through this because I don't have time, but here's my data, and here's my result. Notice something else. I don't let the proportions just run between 0 and 1. You know, I don't know how much students understand, but I want to make a little point here about short selling, and maybe I'll give them some references. And you know, they do occasionally read newspapers, and it would be nice if they said, "Oh, Professor, what was her name again? You know, she talked about this." You know, to talk a little bit and make it a little more sexy. Okay. I think I'm going to skip this. So it's 3:20. I want to take the last 10 minutes and talk a little bit about some pedagogical issues. One issue is, do you teach a course like this in a computer lab? Do you teach it in a class? Do you let people bring laptops or not? My personal preference is to teach it in a class with laptops. At the beginning, I spend more time on Excel. I hope that by the time the course is halfway over, I don't have to go and run around the hall and explain people how to do basic calculations, but at least then they're doing it on their own computer. When I was corresponding with people about this particular talk, I said to the one or two people, "Do you have any suggestions?" And here's Benninga from Illinois State. He's been using the book for quite a while, and his comment was, after he told me how he didn't have the money to come to the FMA, his comment was that his teaching evaluation actually got better when he pulled the course out of a computer lab. Again, I think that's connected to sort of a general point about what it is you're doing. You're not teaching Excel, you're teaching finance. I have another friend who's moved to the Citadel, and one of his suggestions was that he lets people turn in homeworks in groups, and he makes sure that the groups, he gives a basic Excel quiz before he starts the course. And I give one too, by the way. At some point I give one basically just about formulas, get formula, data tables, and then I see what people actually know. And his point was, mix the groups, make sure that they're not just expert Excel groups and non-expert groups. Another issue that I think we've all thought about if you're teaching a course like this is how to give exams. There is an option which I have used, which is to give a closed book exam with Excel clips. I've done this. I've never been especially proud of myself when I do this because it gets me into situations like, here's a picture from a spreadsheet. If you did this, what would happen? Okay? These days, I'm more in favor of open book quizzes with very tight time constraints. I explain to students that the grade, in part, will depend on their proficiency of implementing what they've learned in the course. And I'm not at all sanguine about cheating because I know there's a lot of cheating. I think there's actually less cheating than sometimes I think. But basically what I'm saying to them is, I'm going to disconnect the internet. I'm going to restrict you to using the materials you bring. I know you've got a computer there so you can reference God knows what. Okay? So my trick is, if you know what you're doing, you'll finish the exam. If you don't know what you're doing, you won't finish the exam. People have better suggestions. I'd love to hear them. The last couple of exams, I just gave an exam which was totally internet-based. I had taught a course in Melbourne. We decided that at 2 o'clock in the afternoon in Melbourne, I would send everybody an exam by internet, and I would stay next to my computer for the next 2 hours to answer questions, and they would have to return the exam. Without disrespecting my students, I can say that the grade distribution was definite proof of the fact that there wasn't too much cheating, if you understand what I mean. I've already said some of this. I don't think you should make Excel the focus of the course. Okay, not too many shortcuts. If you want shortcuts, I've got a great reference. I've got a friend named Isaac Gottlieb. Here's his email. He puts out he's also got a book which I blurred, so in the interest of honesty. But he'll send you a monthly email, very nice, with a spreadsheet with some hints. It's very, very good. I try not to do too many shortcuts. There are a couple of things I use. I talked about F4. Another one of my favorite shortcuts is Control-Shift-1, which formats all the numbers in decimal, 2 decimals, and with commas. Drops the dollars. I'm also very open to suggestions from the class. I try to give a lot of credit to people. Somebody has a suggestion, why not? Maybe they know more than I. Finally, if you write me, I have some instructor resources, and one of them is I can show you how to copy from Excel to Word efficiently. So there is this paste as picture feature for Excel 2010 and 11, and you can automate that. And it's a very nice little thing, and you can, it's very simple, and I'll show you how to do that. We have an instructor website for the book. I'm not going to add, if you want a login to this website, we won't ask if you use the book or not. And it's got PowerPoints, it's got some extra problems, it's got a couple of cases that I wrote. I send you the PowerPoints in PowerPoint format, not in PDF format, so that you can, take my mistakes and add your own unique mistakes to them. And that's sort of it.